In regions where fresh drinking water is limited, desalination plants remove salt from seawater, converting it into fresh water suitable for human consumption. There are more than 13,000 desalination plants worldwide, producing 45.5 billion liters of water a day. The desalination plant that produced this drinkable water is located right next to an electrical power plant which uses seawater to cool down its condensers. Post-cooling, the water travels via underground pipes to the desalination plant. Before salt extraction, the water is pre-treated in a multi-phase cleaning process. First, the water flows through screens which filter out large debris. From there, it flows into basins for the first pre-treatment stage. As large paddles agitate the water, the plant adds two chemicals: sodium hyperchloride, a disinfectant, and ferric chloride, a coagulant. The coagulant binds together sand and other tiny particles of debris, forming heavier clumps that sink to the bottom. This removes a significant portion of dirt from the water, but it's still far from being crystal clear. The water now moves into another set of basins for the second pre-treatment phase, sand filtering. Inside each sand filter, regulated by various pressure and flow gauges, a steady stream of air continually moves sand in a circular motion. The seawater enters at the bottom of each filter and flows to the top. As the sand moves downward against the rising water, the dirt particles attach to the sand. The seawater now looks clean, but still contains microscopic particles. So it enters the final pre-treatment phase. This time, the filtering medium is diatomaceous earth, a powdered rock that contains algae fossils. Finer than sand, it filters out those microscopic particles. The seawater is now perfectly clean and ready for salt extraction. They do that using membranes, cylinders containing layers of plastic sheets that have pores 1/1000th the diameter of a human hair, small enough to trap microscopic salt crystals. The plant pumps the clean salt water under extremely high pressure through long tubes, each of which contains 8 membranes. By the time the water passes through all the membranes and reaches the center of a tube, it's completely salt-free. Plant personnel and a slew of sophisticated instruments continually monitor every one of the system's 10,000 membranes. Meanwhile, the plant sends the debris removed earlier to large waste basins for another round of chemical treatment. After the solids settle to the bottom, the dirty water goes back to the front of the plant to be cleaned and recycled. Pressure rollers squeeze the remaining water out of the solids. Trucks then transport the dry solids to a landfill. The extracted salt, meanwhile, goes to the power plant, which dilutes it, then returns it to the sea in a way which doesn't upset the water's natural salinity level. Processing salt water into fresh water strips away the water's natural minerals. Not replacing them would create two problems. First, the water wouldn't taste right. Second, it would damage metal pipes by aggressively trying to replace the missing minerals. Therefore, the plant adds liquid lime and carbon dioxide to the water. These two elements adjust the pH level and raise the alkalinity, restoring the minerals and natural taste.